In this lesson, we will clarify what is meant by controlled, stable or statistically under control, and capable when it comes to a process. And hello again to this lesson, which essentially has two learning objectives. By the end of this lesson, you should have understood why a controlled or stable process is one of the basic requirements for capability studies. Furthermore, you should have understood how the term in control or stable is differentiated from the definition of capability. This lesson is divided into two chapters. In the first chapter, we look at some examples of what is meant by a controlled process. And in the second chapter, we do the same again for capable processes. Let's start with controlled processes. As an example, we take again our tried and tested piston. Its diameter is 60.1 mm with a tolerance of plus minus 0.1. As mentioned several times in earlier lessons, the spread and the process location have an influence on the product and on compliance with product specifications. When assessing whether a process is in control or not, the specification limits of the characteristic are not taken into account. A snapshot of two processes is shown on the right. The left side shows a process result with a broader spread and a process location on the nominal size. The right-hand side shows a process result with less spread and a process location that has shifted from the target value. As I have just used the word snapshot, I would like to point out that a single observation cannot yet be used to draw any conclusions about the future behavior of the process. Only when, as shown here, several samples have been taken, which are staggered in time, can one also make a statement about the future behavior of a process. As shown here, a process is in control or stable if the process result can also be predicted over time. So it either doesn't change or only changes to a known extent or in a known way. Next, let's look at an unstable process. As can be clearly seen in this out-of-control process, the distribution of the values changes significantly from sample to sample over time. A reliable statement about the future behavior cannot be made, which, as already mentioned, should be a basic requirement if you want to assess the capability of a process. So, in a similar way to what we just did for the definition of in-control processes, in this chapter we look at capable and non-capable processes. When assessing the capability of a process, the specification limits of the product characteristic under observation must be taken into account, shown here by the lower and upper limits. This is the only way to determine the yellow parts that will be out of the permissible tolerance. An in-control and capable process is generally capable of producing characteristics and products that meet the requirements with a very high probability. Influences such as the process spread and process location, as well as the tolerance of the characteristic, are used to calculate the capability index. The process shown here is in control, and over time it cannot be assumed that characteristics will be produced that are outside of the tolerance. Here we see a not capable but in control process. In control because the process outcome is predictable over time, but not capable because too many characteristics do not meet the specifications. This is the fraction shown in yellow that exceeds the upper specification limit. The reason for this is a shift in the process location from the middle. An adjustment of the process is required to get a capable process again. Now it's getting wild. Depicted here is a process that is neither in control nor capable. In such a case, it must be examined which influences lead to this behavior and appropriate actions must be implemented. By this I mean that special causes for the variation must be identified and eliminated, and the variation from common causes must be reduced. Can there also be an out of control but still capable process? Well, in principle, yes. This is when, in the case of a process that is not in control, for example, an automated 100% check of a characteristic ensures that only products that conform to the specification are passed on. Well, that was a lot of new information. Therefore, I would like to conclude by repeating the 3 most important key messages. Results of stable or in-control processes are predictable over time. Capable processes are capable of producing product characteristics that meet the requirements with a very high probability. See also capability indices. Special causes for variation must be identified and eliminated. If you found this lesson helpful, please let me know and leave a comment. Thank you for that, take care and see you next time. Bye.